The Atlantic Test Ranges. Fully instrumented, fully integrated support for testing, training, and experimentation. Helping naval aviation move forward from one generation to the next. Today's battle space is growing increasingly complex, and the aircraft operating in it are growing more complex as well. Yet, aviation systems must still be able to operate as an integrated force across the Navy and with other U.S. forces and foreign partners. This ever-growing complexity places greater and greater demands on test and evaluation. So ATR has evolved beyond basic open-air flight testing to determine compliance with specifications. It now supports testing, training, and experimentation to determine the capability of aviation systems to perform their missions. It's not possible to reproduce the actual battle space where a mission takes place, but relevant portions of it can be replicated through the virtual and constructive capabilities of the Naval Air Warfare Center Aircraft Division, NOC-AD. A constructive scenario can be created in a computer to carry out a test in a simulated battle space. And a computer simulation combined with interactive hardware can reproduce an even more realistic virtual environment. Integrating both with ATR's extensive open-air capabilities creates a seamless T&E environment of live, virtual, and constructive LVC. The result is better technology and tactics delivered faster to the fleet. ATR is located at Naval Air Station Patuxent River, Maryland. It's NOC-AD's open-air test range and one of 3 test ranges within NavAir. Patuxent River has 5 active runways. The longest is 11,800 feet. A few miles south is PAX's Webster Field Annex. It has 4 runways, each 5,000 feet long. Webster handles additional daylight testing and UAV operations. Aircraft from PAX have access to both inshore and offshore restricted airspace. Inshore is the Chesapeake Test Range. It covers 2,400 square miles with altitudes up to 85,000 feet. Offshore is the Atlantic Warning Area, 57,000 square miles with unlimited altitude. It's ATR's main location for weapons integration and long-range sensor testing. ATR controls offshore testing through network connections with NASA's Wallops Flight Facility on the Virginia coast. When not supporting NASA missions, Wallops can provide radar, refueling, telemetry relay, and target launches for ATR. Data and communications flow between Wallops and ATR through high-capacity fiber optic networks. Additional networks connect ATR to other mid-Atlantic ranges and laboratories, to Naval Air Warfare Center Weapons Division ranges, and to DoD test and training ranges nationwide. Test teams at ATR can monitor events at these other ranges or conduct a test at PAX and send the data to teams across the country. For aircraft under test, ATR supplies all necessary range capabilities and can develop new ones when needed. The Range Control Center provides real-time air and sea traffic control for all missions. Aircraft time, space, and position information, TSPI, is provided by electro-optical systems, tracking radars, and GPS instrumentation systems. ATR also provides dynamic radar cross-section measurements for a range of frequencies with ATR's Advanced Dynamic Aircraft Measurement System, electronic warfare environments that simulate adversary radar and communications from multiple emitters, and video imagery from high-powered cameras. The cameras document open-air testing in full-color video, high-speed video, and short and long-wave infrared. High-speed video allows precise measurement of position and movement through a process known as photogrammetrics. Targets available for ATR testing include Hooper Target and nearby Hannibal Target in the Chesapeake Bay. Aerial targets are provided by Atlantic Targets and Marine Operations. On land, Atmos supplies realistic replicas of combat vehicles to represent opposition forces, and at sea, both towed and self-propelled targets. Atmo also maintains a fleet of support vessels, including seagoing ships for offshore work. ATR's Range Safety Office uses Atmo to clear vessels from hazard areas. For large-scale tests over the ocean, aircraft are used for clearance operations and instrumentation relays. Data generated during testing is received by telemetry antennas. They're strategically placed around the range for uninterrupted reception, regardless of aircraft maneuvering. Telemetry data flows back to one of 12 mission control rooms. There it's processed, analyzed, and displayed with ATR's Real-Time Telemetry Processing System, RTPS. Each room holds from 30 to 40 controllers, engineers, and analysts. These rooms can process tens of thousands of separate measurements, such as airspeed, altitude, and angle of attack. Test engineers can use the data in real time for quick decisions during a flight and record it for post-mission analysis. Mission control rooms are just one of the ways ATR engineers have created or adapted capabilities to meet customer requirements. Here are some other examples: the Automated Communications Test System and the Mobile Battlefield Communications Simulation System. They broadcast partners or adversaries' voice communications in their native language. The Broadband Emitter Antenna Measurement System. BEAMS is a reprogrammable radar receiver system developed for the next generation jammer. The Patuxent River Infrared Signature Measurement System. PRISM is a transportable system for measuring IR and ultraviolet signatures locally and at remote test sites. The NOC-AD Spectrum Monitoring System. NSMS tracks down sources of interference in the telemetry, communications, and command and control portions of the radio frequency spectrum. And weather monitoring instruments and forecasting services to track atmospheric conditions for tests. ATR mobile units incorporate all the range capabilities necessary to take flight testing on the road: radar, telemetry, electronic warfare, electro-optical, IR, GPS, and weather instrumentation. Flight test data can be acquired wherever needed, on land or at sea. ATR can set up communications networks, install instrumentation and telemetry networks, and analyze data to determine whether test points have been met. Fleet operations are complex. To simulate these real-world conditions, ATR has developed extensive network links with virtual and constructive assets. A prime example is NOC-AD's Surface Aviation Interoperability Laboratory. SAIL replicates the combat and sensor suites found in naval vessels. ATR is also networked with the Air Combat Environment Test and Evaluation Facility. Here, live aircraft can be fully integrated with an even wider range of virtual and constructive assets. ATR's developmental testing capabilities have proven equally valuable for training and experimentation. For example, Atmo provides watercraft for warship crews to train against swarm attacks. And T&E combined with training naturally lends itself to fleet experimentation. What happens when a new technology is introduced to the fleet? With its virtual and constructive links, ATR can create a complete battle space environment for fleet experiments. Systems are tested to see if they work as advertised, not just individually, but together, and as close to real-world conditions as possible. All these Atlantic ranges and targets resources can be brought together for the following types of testing: flying qualities and performance, store separation, weapons integration, carrier suitability and shipboard integration, mission systems, target presentations, and special projects such as the Army and Marine Corps Switchblade and NAVSEA Hellfire missile tests. ATR is uniquely positioned to integrate these open-air capabilities with the virtual and constructive world. And that lets it test like the Navy fights, to help develop new generations of naval aircraft, bring the latest technology and tactics faster to the fleet, and shorten the kill chain for the warfighter.